All right. Welcome everybody to this week's community show, Optimizing Your Reltio Implementations with CI/CD. I'm Sarah Brahms Miller, and I am the Community Program Manager at Reltio. I'd like to introduce Snehal Kamal. He will be the one who will be presenting today. Snail, if you can go to the next slide, please. Couple of housekeeping items, of course, as usual, before we begin. Um, these sessions are all recorded and posted to community, so please keep yourselves on mute. If you have questions, you can either ask them in the chat or you can wait until the end of the session where we will have a Q&A portion. And you can, of course, ask a question during the Q&A. If you can go one more slide past. Take a quick look, brief look at this slide. It is our safe harbor slide. We always have this presented anywhere. And then Snehal, I will pass it over to you.
Thank you, Sarah. So, thanks everyone for joining. In terms of agenda, we have a lot of content to cover today. So, we'll start with the basics of CI/CD, the various phases of CI/CD, the benefits of CI/CD, of course, for the Reltio implementations. I have some tool recommendations and also some recommendations on the branching strategies. Finally, we'll go through the CI/CD lifecycle for the various Reltio components and the different steps involved. We'll end with the demo, a brief demo, and some of the limitations that we have today. So I would organize the content in a way that I'll probably spend first uh, 20 to 30 minutes on the slides. Then I'll jump to the demo, and the last section would be Q&A. Basics first, as I said, what is CI/CD? So CI/CD stands for continuous integration and continuous deployment and delivery. So it's a set of steps basically to automate and streamline your software development. And we are talking in context of the Reltio development in this presentation, right? And once you implement CI/CD, will make sure that you can deliver high quality software more reliably and in a faster fashion, right? So in the picture, you can see there are various steps involved in a CI/CD process. Starts with planning, coding, building, then testing, then release, which is the most important one, right? Followed by deployment and operations. Moving ahead to the next slide, the different phases of CI/CD. The first one is continuous integration. So it's a practice of frequently merging the code to a shared repository. For example, a Git repository where developers can collaborate and frequently merge their configuration and code artifacts into that repository through different branching mechanisms that we'll talk through later in this presentation. Continuous delivery would ensure that the code passes through all the standardized testing procedures, making sure that there's sufficient quality assurance that is done before deployment and the code is deployment ready to production at any time. And finally, continuous deployment. So it's the next step after the testing or the quality assurance process, which automates the actual deployment to the tenant or environment of your choice. So every successful code change which passes through this pipeline, the CI/CD process would automatically get deployed to production or any other environment of your choice, right? So these are the three phases on a high level. Continuous integration is the first thing, then delivery, and finally the deployment. Moving ahead, the benefits of CI/CD for Reltio implementation, and it's not just for Reltio implementation. I mean, these benefits are across, like for any software development lifecycle. These are the broad benefits of CI/CD. It ensures faster development because, most of the steps are automated. There is hardly any manual stuff. Improved code quality because there's automated quality assurance or automated testing, as we call it. There's enhanced collaboration and transparency where multiple developers or multiple um, configurators can work on the same piece of code and everyone knows what the other team member is working on. So there's transparency, there's collaboration, and there's less risk of overwriting each other's code through a CI/CD process. And finally, as a byproduct of all these, there's reduced manual work. There's no human or least human error, I would say. We cannot, promise a perfect world where there's no error at all, but the probability of human error reduces because most of these steps are automated. Moving ahead to the next slide, these are some recommendations of the tools. And just a disclaimer, these are not the only tools. There are many tools that are available in the market to implement a CI/CD process. I would suggest starting with the tool that is already approved within your organization and used for other deployments. But if you're starting greenfield and there's no CI/CD process established, you can take a look at one of these tools to implement the end-to-end CI/CD process, right? So the first one is the code versioning tool, right? So there are different tools or frameworks available. Git is the most popular one. It's a distributed version control system, very strong branching and merging mechanisms, and widely supported. So most of the open source projects are delivered using a Git-based software these days. It's best for teams of all sizes, and as I said, it's well suited for open source projects. But I mean, it doesn't restrict you to use Git for even Reltio implementations, right? So it's equally suitable for the enterprise projects as well. Subversion, also known as SVN, is a centralized version control system. It was very popular a decade back, right? It's simpler without much branching complexity, but doesn't offer a lot of functionalities what Git does. It's best for legacy projects, right? Like many legacy customers still use it, and enterprises who need strict strict version control, they prefer Subversion. The final one is Mercurial. It's also a distributed version control system, simpler than Git in many aspects, and performs well with large repositories. So the teams who are looking for a user-friendly Git alternative can opt for Mercurial. Not very popular, not as popular as Git, but it's good. It serves the purpose. Next are the recommendations for pipeline tools. Pipeline is basically a set of steps that are incorporated in a CI/CD process. We'll talk more about that later. But in terms of developing your pipeline, you have different options available. There's GitHub Actions that is integrated within GitHub. You can write your CI/CD steps using GitHub Actions. There's GitLab CI/CD, which is similar to GitHub Actions but suitable for GitLab. And then there's Bitbucket Pipelines. It's an equivalent for Bitbucket. In the demo, we will use Bitbucket Pipelines to demo a CI/CD lifecycle for Reltio. There's Jenkins, which is a highly customizable tool, right? Very popular, open source. It supports lot many things compared to the GitHub Actions, GitLab CI/CD, and Bitbucket pipelines, but it's not integrated into one of these version control tools. It's independent, open source. It needs to be integrated separately, right? So the teams needing full pipeline control and high customization can opt for Jenkins. Next on the slide are the various scripting tools. So generally, scripts are written um, to do things like automated testing and automated deployment, right? So we'll look at some of the scripts later, but these are various tools, or I would say languages or scripting tools, which are you know um, used for writing these test cases or deployment scripts. So first one is Shell. It's simple, direct command line execution, and very compatible for all the pipelines, all the version control systems. It's used for quick automation scripts and small tasks. Python is a very popular scripting language, platform independent, and works very well for complex logic and integrations. It supports automation heavy workflows, and very advanced scripting. Node.js is ideal for GitHub Actions. It supports asynchronous processing for speed, um, and it's best for JavaScript heavy projects and GitHub related automations. Finally, Groovy, that is native to Jenkins, and it supports declarative and scripted pipelines, very powerful again. It's suitable for Jenkins users who need extensive customization, right? So these are the four. Again, as I said in the beginning, these are not the only four. There may be other languages, other scripting tools that you can use, but these are the most popular ones. Um, Moving ahead, I have two recommended branching strategies that you can use when you are implementing version control and CI/CD pipeline, right? Again, these are recommendations. You can always, stick to the branching mechanism that is already used in your organization. You need not to look at these, but you are starting from scratch. These are some of the recommendations. First one is GitLab Flow. It's called GitLab Flow, but it's not like it works only with GitLab. It works with all version control systems. GitLab is the one who pioneered this, so it's named after that, right? So it has this flow offers many different branches. So the primary three branch types are development branch, environment branch, which is called a staging branch in the diagram, and a master branch, right? It's suitable for the Reltio implementations because most of our customers have multiple tenants for different purposes. Three tenants is the most common approach where there's a development tenant, test tenant, and a production tenant. So with this strategy, you can maintain the version of code deployed to those specific tenants in different branches, right? So there are three branches, and there can be different feature branches, right, where the actual development happens. So basically, the developer does the changes on the feature branch and merges the code to the development branch. So that's the life cycle, or that's the step followed, right? And there can be multiple feature branches depending on the feature that are developed in agile methodology, right? The environment branch, as I said, allows for testing, QA, documentation updates, etc. Right? So code in the development branch, once it is passed through all the unit testing and verifications, it gets promoted to the environment branch, which is the staging branch in this example, right? And there can be multiple commits from the development branch that can go together into the staging branch. So there are two commits here depicted, which goes to the staging branch together, and the two commits from the staging branch goes to the master branch or the production branch, right? Um, and this happens once all the verifications, QA testing, SIT, UAT, etc., is completed in staging. It gets promoted to the master branch, right, which is the production branch. So it provides the flexibility, as you can see, where you can maintain the code bases from the different tenants and the different branches, right? And it's very popular, used by many of our customers already. The second recommendation here is a simpler version or a simpler branching strategy. It's called trunk-based development, right? Where there is one master branch. We also call it as trunk branch, right? And if it's a smaller team, smaller organization, um, developers can directly commit to the trunk branch, right? And they can tag the commits based on where that commit is getting deployed. So there can be a tag for development, there can be a tag for staging and production, etc. Right? But there are no separate branches for those tenants. There's just one branch called the trunk branch. There can be short-lived feature branches, as I depicted in the previous slide also, right? So that's more suitable for larger teams. If many multiple developers are working on the same piece of code, they can use these feature branches to do their localized development and then push the feature branch to the master branch and tag it accordingly. Um, Optionally, a release branch can also be created to club all the features related to a particular release, right? So there can be multiple releases, and the features for that particular release can go to the specific release branches. And once the release is over, the release branch can be deleted, right? So on a high level, the main branch here is the trunk branch. Feature branch and release branches are optional. This strategy encourages DevOps best practices, and the prerequisite for this is the team should have strong automation and a robust CI/CD pipeline uh, to be successful with this branching strategy. Moving ahead, so this is the CI/CD life cycle for the Reltio components, right? Like how or the recommended way to follow the branching strategy. And here I've focused on the first branching strategy, which is the GitLab flow, right? Step one is developer creates a feature branch from the remote development, staging, or production branch. One of those branches can be baseline, create a feature branch. And I'll show this in action, like towards the end. But just to understand the steps, first step is to create feature branch. Second step, a developer does the code changes on the local copy in the feature branch, right? And then the developer creates a pull request to merge the feature branch to the remote branch, right? Once the pull request is approved, it's usually approved by a team lead or a lead developer in general circumstances, right? Once that pull request is approved, the CI/CD pipeline is triggered, which deploys the code to the development environment, right? And also it does the necessary verifications based on whatever verification steps you have incorporated in the pipeline. Before the deployment, the pipeline should compare the code which is already deployed in the environment, right? Let's say you're deploying a business configuration or L3 configuration, right? So before even deploying the new configuration, it should compare the deployed code with the code available in the branch before the current commit, right? And if they're not the same, then the commit or the deployment should be aborted, because if you don't do that, there is a possibility that you may override the code which is already deployed through a different mechanism. Ideally, this should not happen in a strict process governed CI/CD process, but there's always a possibility, and if it happens, it's best to compare the code before deployment. If the pipeline fails for any reason, the notification should be sent to the necessary participants to take the corrective actions, right? This can also be incorporated, and this is available out of the box in most of the popular CI/CD tools. And once the feature is verified in dev after deployment, another pull request can be created to merge the code from development branch to staging branch, right? And rest of the steps would be similar to the development branch. So, uh, I mean, this step can be manual, this can be automated too, depends on the how mature is your CI/CD process, right? So initially, I would recommend going with a manual pull request creation step, but once you're mature enough and you're confident about all your automated testing steps, then probably there is a possibility to, directly um, start deploying in the test tenant once the code is verified in dev. So that's definitely a possibility. Again, depends on how mature your automated testing steps are, right? And similarly, once the SIT UAT is finished in the staging or test environment, a pull request can be created to merge the code to the master branch, which deploys the code to the production environment, right? So again, through a CI/CD process. So this completes the end-to-end CI/CD lifecycle. Starts from feature branch, goes to development branch, code gets deployed to development, then goes to staging branch, where the code gets deployed to the test tenant, and finally to the master branch, which deploys the code to the production tenant. So these are the high-level steps. Just a note here, right? So whatever steps I have depicted here is suitable if you do configurations on the source files directly, like the JSON configurations. But if you're doing changes to the UI, to data modeler or UI modeler or things like that, right? So if you do that, then automatically whatever changes you're doing gets deployed to the development tenant if you're doing the changes in development, right? But even with that, you should still pick up the relevant configuration artifacts. For example, if you're changing something in the data model, you should pick the business configuration JSON file and you should push it to the feature branch and create a pull request to merge it to the development branch. I mean, same set of steps, but difference is since you do the configuration directly through the UI. The changes would get deployed first, and then it will go through the CI/CD process, and the CI/CD user will again deploy the same changes. But at least it will make sure that your deployment process is standardized, and all the automated testing and verifications are carried out through a CI/CD process, right? So um, that's a little caveat for the UI based deployments. Um, Moving ahead, in terms of low level granular steps that you need to follow for the deployment or to implement CI/CD for Reltio components, there are three broad steps. First are the pre-deployment verifications. So these are the automated verifications that triggers even before the deployment happens, right? And we'll go through what are those in the next slide, right? So this happens pre-deployment. Second is the actual deployment, where the actual build or the deployment happens for a particular component. And finally, there are post-deployment verifications. So once the deployment is done, you can do a smoke testing, or you can trigger the automated test scripts to check if the deployment was successful, right? So broadly, these are the three steps you have to follow, right? Um, if the verifications fail due to any reason, and that's the note I have put on the bottom, right? If the verifications fail, then the commits and the deployment can be rolled back. So even that can be automated, right? And most of the mature CI/CD processes follow that, so that is least manual intervention. So here I have listed down the various components and the different kind of verifications that can happen for those components, right? So the most important one, or the most common one, is the tenant's business configuration, popularly known as L3 configuration, right? So when you are um, pushing a L3 configuration through a CI/CD process, in terms of pre-deployment verification, you can do, or you can validate the JSON structure, check the correctness, or if check if the JSON is syntactically correct. You can also check if the L3 configuration has any errors. You can run the L3 validate API to check if there are any errors even before deploying it, right? So all this can be automated. In terms of deploying the business configuration, you can use the Reltio API for deployment, right? The standard API that you fire using Postman. And you can monitor the API response for any errors and take the corrective actions or roll back the deployment if there are any errors. In terms of post-deployment verification, after this change, you can test posting a sample entity or relation to see if everything is getting posted correctly into Reltio. You can test auto merging. You can test suspect merge creation to check the validity of your match rules, and you can also fetch the latest L3 using the Reltio API. You can basically doing a get of the L3 and check if everything got deployed correctly. Right? These are some indicative post-deployment verifications you can do. Similarly, for RDM configuration, in terms of pre-deployment, you can validate JSON structure. You can use the standard APIs, Reltio APIs for RDM deployment, right? Monitor API response for any errors. In terms of post-deployment verification, you can test posting the lookup mappings, types, sources, etc. And you can fetch the latest RDM config using the Reltio API and validate, right? Very similar to L3, but the set of APIs, the set of verification steps may differ, and you can all automate it, right? Um, for LCAs, the steps are different, right? Because it's a custom component, usually deployed as a Lambda function, or um, as a function in GCP. So in terms of pre-deployment verification, it can be very exhaustive. You can check the code for any errors, so-called code linting. You can do vulnerability checks on the code. You can check the code coverage, and you can do test class executions on the LCA code, right? So most of these things are already done whenever LCA is deployed, but mostly done manually. But you can do it automatically using a CI/CD process. Once all these pre-deployment verifications are done, you can build the code using and it depends on the language using which you're writing LCA, right? So you can use the standard code build processes to build the code. And if it is a AWS Lambda-based LCA, you can use AWS API to deploy that as a Lambda function. There can be equivalent in GCP too for this, right? In terms of post-deployment verification, you can invoke the LCA Lambda function with a sample payload and verify the response, like whatever you intend to do with that LCA is working fine or not. So these are the steps for LCA. For workflows, in terms of pre-deployment verification, very similar because workflow is also a custom component, and I'm talking about custom workflows here, right? Like you have to do all these vulnerability check, code coverage test, and so on, even for LCAs, right? With the new deployment process of LCA, even Reltio standard deployment process does these things, but you can proactively do all these checks on your side before even um, sending this for deployment, right? You cannot deploy the workflow code directly using any API. So the workaround is once you have done all the pre-deployment verification, you can push the workflow code to the Reltio's Bitbucket repository, right? And once you do that, the standard workflow deployment processes invoke on its own, right? So that's a workaround. You cannot do post-deployment verification for workflows because it's not deployed in real time. It goes through a set of steps in the Reltio's Bitbucket repository, but you can always do those verifications offline outside the CI/CD process. Um, Metadata permission is also a JSON, so I'll interest of time, I'll skip it. Like it's similar to L3 and RDM. You have to do JSON verification and use the Reltio API for deployment, right? For RIH, it's different, right? So RIH deployment is a completely different process. So here you can validate the RIH manifest for any errors, and there are standard ways of doing that, right? Under pre-deployment verification. Um, in terms of deployment, you have to use the RIH APIs for manifest deployment, right? Right now, most of you will be doing it manually using the UI, but there are APIs available to do the manifest deployment, right? You can monitor API response for any errors. In terms of post-deployment verification, you can simulate the recipe triggers, or you can even, test the recipe programmatically to check for any errors or verify the job execution. So these are the steps available for RIH. Um, for DTSS, it's again a JSON-based configuration where you can validate the JSON structure for pre-deployment. You can do more, but it's just indicative, right? You can use Reltio API for deployment, and you can also invoke the verify subscription API once the deployment is done to make sure everything is deployed correctly. In terms of post-deployment verification, you can import a profile from DT to CT and validate if everything is working fine. And you can also create a profile in CT and validate the subscription trigger. So all that can be done uh, as a post-deployment verification for DTSS. For data validation functions, again, a JSON component. So pre-deployment verification is same. You can use the DVF APIs for deployment, right? And in terms of post deployment, you can simulate the success and failure scenarios for the DVF and check if the errors are thrown correctly, right? So that's about DVF. Saved searches, then simple JSON-based deployment that you can follow using the standard APIs. As a post-deployment verification, you can fetch the saved searches that are saved in the tenant and validate if the one that you deployed is present there or not, right? And of course, you can test if it is yielding the correct results. The three more components, data loader mappings. Here, again, you can use the Reltio APIs to deploy the data loader mappings and monitor for any errors. You can also execute a simple data load using any sample file as a proposed deployment verification, and you can validate the results. Of course, if it is production, you cannot do all of it. You can, and even if you're doing, you have to delete what you have loaded, right? So you have to keep that in mind. Um, in terms of UI configuration, there are certain limitations here, though you can validate the UI configuration JSON files as a pre-deployment verification, but we do not have any standard API for UI configuration deployment. So the deployment cannot happen through a CI/CD process. It needs to be manual. That's one of the limitations we have currently, right? But you can still do the post-deployment verification where you can load the UI programmatically and check for any HTTP errors while loading, right? Uh, the final thing is users, roles, and groups, right? So here again, it's all JSON based um, uh, configuration, right? You have to ensure all the mandatory details are present for any user role or group creation. For example, for any user creation, email is mandatory, so you have to check whether email is present in the deployment script, right? You can use the Reltio API for deployment, right? And finally, during post deployment, you can use a get API to verify whether all the created roles, users, and groups are created properly. So yeah, these are the exhaustive list of Reltio components and the various uh, pre-deployment, deployment, and post-deployment steps that you can follow. But again, these are indicative, right? These are some high-level steps or common steps that you can use, but depending on your use case, your implementation, you may have more, right? You may have use case specific or your flow specific verifications that you may want to do, right? But all that can be incorporated in the CI/CD lifecycle, and I'll in the demo I'll show a framework on how I have built a pipeline where you can easily integrate any new verification step or deployment step, right? So it's not that difficult, and you'll get to know during the demo. Yeah. Going ahead for the demo, let me stop sharing and share it again. Fine. So for the demo, I'm using Bitbucket version control system. So this is the screen that you see right now. I've created a repository that's called Reltio CI/CD, right? In this repository, there are various branches. So as I said, I've used the GitLab branching strategy for this demo, right? So there are three branches. Master branch corresponds to the production code, is development branch and staging branch, right? So I can I can switch to different branches from here. So this is my development branch, right? And I'll show you how to create a new feature branch and integrate or commit the code to the feature branch and merge the feature branch to the development branch, right? But for now, this is how the branching looks like. There is another important uh, or interesting thing here called deployments, right? So we have the different deployment environments that I have created here, right? Is development, test, and production. This is slightly are this different from the branches that I showed, right? Like, but each deployment environment correspond to a branch. For example, the development environment corresponds to the development branch, test environment corresponds to the staging branch, and production environment corresponds to the production branch, right? So these are the different deployment environments. If I just click on this gear icon here, so you can configure the environment variables for each of these deployment environment, right? So for example, for development environment, I have a client ID, client secret, environment, and tenant. So what it means is when you're trying to deploy something in the development tenant, for example, it will dynamically pick the environment name, client ID, client secret, and the tenant ID for the development tenant and use these details to deploy any code to the development tenant and to do any post-deployment or pre-deployment verifications, right? So the client ID and secret can differ for each deployment environment or tenant, right? So these are for my dev deployment environment, right? So I have similar variables configured for my test and also for production, right? Production, I have not configured anything for the demo, but um, I can configure if required, right? So I have these three deployment environments, right? And I'll show you in some time like how the branches are related to or how the branches are interconnected to these deployment environments, right? But for now, um, for the demo, what I'll do is I'll um, I'll go to my source tree application, right? So this is a front-end UI where I which I use to commit changes or manage any changes to the different branches or I have to the repository, right? So let's say um, I'm a developer and I'm tasked to add a new source in the business configuration, right? So that's my use case for today. To do that, what I'll do is, first of all, I'll create a new branch here. So right now you can see just the development and master, right? So I'll create a new feature branch. It's important that I follow some strict naming conventions for these branches so that people don't confuse it, right? So let's say I name it feature branch new source edition, right? So this is my name of the feature branch. I'll check out this new branch, click on create branch. So I'm creating it from my development branch, right? I can also do it from the master branch if required. For now, I'm creating it from the development branch. So yeah, the new branch is created. Now the code base corresponding to this branch is checked out in my local machine, and I can show it here, right? So this is the code base corresponding to the new branch that I just checked out using the development branch. So this is the folder structure that I'm maintaining, right? So there are specific folders for different kinds of configuration. So for the demo, I'll just show business configuration, which is L3 or and the metadata permission, but you can have different folders for all the different kinds of configuration like L3, workflow, DTSS, and so on, right? There is a source folder, right, which contains the different scripts or source codes which are used for in the CI/CD process, and I'll come to that later in the demo. But just to um, complete what I was trying to show, right? So I created a feature branch, and I'm tasked to add a new source in the business configuration. So I'll just open the business configuration L3 file. So this is my L3, right? I'll add a new source, and I'm doing all these changes um, uh, through JSON. I'm not using the data modeler for this demo, but you can use it, right? And as I showed, as I told previously, if you are using data modeler, you have to um, commit the changes again using the same process. But for now, I'm just doing the changes directly to JSON, right? So let's say my new source is a CRM, right? So I'm just calling it CRM for now, right? So uh, let me label it CRM. Even the abbreviation would be CRM, right? Um, and I'll just change the version or I'll increment the version from 1.28 to 1.29, right? So this is the change I have done. I'll save this file. So as soon as I save it and when I open my source tree application, it shows a number one here, which means there is one pending file which is yet to be committed, right? And that is unstaged right now, right? So if I click on this, it shows the exact changes what I have done, incremented the version number from 1.28 to 1.29 and added a new source here. I'll click on stage, right? So this is the first step. You have to stage the unstaged files. Then click on commit, right? So I'll say added a new source as part of user story. Um, let's name it 12345, right? Uh, Click on commit. It's important that you provide a readable commit message. That's the best practice for any um, collaborative development, right? So the file is already committed. Now it doesn't, I mean, if it is committed, it doesn't mean it's already pushed to the remote. It's still sitting on your local machine, right? So to push it to the remote branch, you have to click on this push button. And there are equivalent commands for this. Like you can also use command line interface to do the same thing, but for the demo and for the to make it intuitive, I'm using this tool. So this is my branch and this is my local branch. I want to push it to the remote branch with the same name, right? I'll just click on push. So what this will do is it will create a branch, a remote branch in the Bitbucket repository with the same name, right? And it will push all the changes from my local branch to the remote branch. So the remote branch will appear here, right? So this, whatever you see here is the local branch, and whatever you see under remote are all the remote branches that I have, right? So this is my remote branch, right? Now, the next step, as per the life cycle that I demonstrated, is to um, create a pull request to push this remote branch to the development branch. I can do that from here too, right? So I have to right click, create a pull request. This will take me to the Bitbucket UI, right? So here my source branch is the branch that I just created. Destination branch would be development, right? And you can restrict from which source branch, or based on users, you can restrict like who is allowed to create pull requests for which branches, who is allowed to approve, reject, etc. All those features should be present in any standard version control tool, right? So as soon as I do that, the title already populates. You can add a description if you want. You can add reviewers. Right now, I'm the only user, so I would be the reviewer, right? But in a collaborative environment, you can have uh, uh, designated reviewers for any pull request, right? I'll just create a pull request. It's created. Next step is to approve. In real life scenarios, the developer who creates the pull request should not be the approver, right? So the team lead or a peer should be the approver. But for now, I'll just approve it. You can also configure to have more than one approvers if required, right? But once it is approved, you can just merge the code, right? And in the commit message, you can specify whatever you want, but it gets auto-populated too based on the commit that's getting deployed, right? So I'll just click on merge. So what this will do is this will merge the code from the feature branch to the development branch that I showed earlier. And as soon as that happens, as soon as the code gets pushed to the development branch, it triggers a pipeline, right? That you can see here. So this is the pipeline section, and the pipeline is in progress. And pipeline contains a set of steps, pre-deployment verification steps, deployment steps, and post-deployment steps, right? That you can see here. So the pre-deployment verification is running. It would be followed by deployment and post-deployment verification, right? So whatever you see here, the steps, the pipeline steps are all written in a YAML file. That's what we call it, right? So it's called Bitbucket pipelines.yml, right? So it contains the series of steps that gets executed as part of that pipeline. And while that pipeline runs, I'll quickly run you through or show you what those steps are. So this is my pipeline.yml file, right? So it starts from here, right? So you should start reading it from here, pipelines, right? So inside this, there are three different branches: development branch, staging branch, and master branch. So what it means is when the code is pushed to the development branch, what I'm showing right now, right? So whenever the code is pushed to the development branch, this section of the pipeline gets executed. So these are the steps that are being executed right now, right? So step name is deployment to development environment. And this is my deployment environment that I showed earlier, right? So it's called development. So what it means is these steps will refer the environment variables that are configured for the development deployment environment that is configured in Bitbucket, right? So making sure that the code gets deployed only to the development tenant and not all tenants, right? So this is important to specify. There are three high-level steps here: pre-deployment verification, deploy, and post-deployment verification that I showed in the deck. In terms of, and if you want to see what these steps are, the first is pre-deployment verification, which is here, right? So the definition of this step is here. Like it's like a function in any programming language. So pre-deployment verification is a function. You can take that analogy, right? What it does is it first checks as part of the commit what all files are changed, right? So it puts those changed files in a variable called changed file, right? And then it will, uh, based on what is changed. For example, if the business configuration is changed, it will invoke the pre-deployment verification for the business configuration, right? So there is a Python file that gets executed here called pre-deployment verification.py, right? So this file will invoke or will basically check the JSON structure of the L3 configuration, etc., right? And it will pick the file from the same repository, which is this is the folder structure, business configuration slash business configuration.json that I just changed, right? Which is here. So it will pick that file, perform all the pre-deployment verifications, and see if everything is accurate, right? Similarly, if metadata permission is changed, it will do the pre-deployment verification for the metadata permission component, right? And you can extend this for all the Reltio components. This is just a framework as an example, but depending on the change that is done, it identifies what is changed and it will run the pre-deployment verification for that particular component. The deployment is also very similar, right? So deployment steps are here. So the second step, so depending on the type of configuration that is changed, the deployment steps would differ, right? So for example, if the business configuration is changed, it would invoke this script called deploy business config.py, which will invoke the deployment of business configuration JSON file. If metadata permission is changed, it will invoke the deployment for metadata permissions, right? And so on. Very similar is the post-deployment verification. So depending on the component, it would invoke the particular file, right? And for this illustration, in terms of pre-deployment verification, I'm just checking the structure of the JSON. For deployment, I'm invoking the business configuration deployment API to deploy the business config. For post-deployment verification, I'm creating a new entity to check if the creation is successful, right? So those are the steps I'm following. And those are the only three steps, right? So you can extend it as per your needs. Um, this example will serve you as a framework on how you can build it or how you can extend it for your use cases, right? So let me go back to my pipelines, right? So and refresh the page. So the pipeline run is completed. It's all successful, right? So there are no errors. So you can see the three steps are invoked. First is pre-deployment verification, right? And you can, whatever comments you have in your Python script or in your YAML file gets printed here, right? You can um, check towards the end. So it says there were changes detected in business configuration, right? And it checks the business configuration pre-deployment script. It checks the JSON is syntactically correct. And finally, it says the verification is successful. After that, it deploys the L3 JSON to the tenant using the standard Reltio APIs, right? Again, um, you can see a success message here. If there is any failure in the deployment, this step will fail and you'll see a failure message. And finally, it will do the post-deployment verification where it mm, runs few test cases. So I have just one test case here and it says the test case passed in 55.71 seconds, right? Um, so yeah, this completes the pipeline, and I'll quickly show just to verify if everything got deployed correctly, right? So I'll just do a get configuration on that tenant where I deployed this. Um, so you can see the version is 1.29, right? Which is what I deployed. right? It matches here 1.29, right? So that got deployed, and uh, the new source CRM got added in the tenant. So all this happened as you saw through the pipeline. I did not invoke any APIs manually, right? So all this is automated. Um, Going back to the final slide I have, the demo is complete, but the final slide is around the limitations. So UI configurations I already spoke about. So we do not have a programmatic way to deploy UI configuration, right? So that needs to be done outside CI/CD process. And code versioning, we do not offer the out of the box versioning capability for any code and configuration. So it's possible that the pipeline can deploy the older version of the code and override the newer version. That's a possibility. To mitigate this, you can do a code comparison before deploying, again using the standard scripts or a pipeline-based process. Right? So you can mitigate it, but again, Reltio doesn't offer a standard versioning capability. Um, I think that's it from my side, and we can go to the Q&A now. I'll just open the chat.
I have it open, Snehal. I can read them out to you.
Sure.
Um, Utsa has asked how some of the components like UI Modeler RIH can be automated for deployment as they are mainly deployed through UI.
Great question, Utsa. And as I just spoke about the UI based deployment, right? So it's a limitation. We cannot do that. We do not have an API yet, but I think that's something being considered for future releases. So right now you cannot automate it. RIH can be automated. So there are ways to automate the deployment of recipe manifests, and I can follow up offline to share some of those um, scripts for deployment.
The next question that has not been answered yet is, do we have a way to transform Workato manifest in order to deploy it to different tenants? Example, mapping change.
Um, Do we have a way to transformer? Ashish, can you clarify that question? What do you mean by
Yes, Neil.
transformer Workato manifest?
No, not transformer, but that's a typo. To transform. So let's say we have a Workato
Hmm.
manifest in one
Okay.
environment, and
Okay.
due to some reason, it needs to be transformed. Let's say Reltio mapping, right? It needs to be transformed from one environment to another environment. So how we
Right.
have for every CACD we will have certain variables, correct, which
Hmm.
changes based on tenant. So is there a
Right.
way to programmatically change the Workato manifest?
Good question. I think you can, because whatever you have in the recipes are present in the backend JSON. Like when you
Right.
unzip the manifest, you'll have JSON files. So you can programmatically change the content of those JSON files to do what you want, right? But um, uh, I mean, it requires some due diligence, and you have to make sure that you test whatever you change. Um, Technically doable, but requires some testing for sure.
Okay. And then I can find Percarto APIs in order to deploy it.
Yep, yep, that's correct.
Thank you, Sneh.
Go to the next
So,
one.
if multiple data models are being maintained in the same tenant for different domains and changes need to be done parallel in L3Y by different applications in the same tenant, which branching strategy would be suitable so that any application does not need to have any dependency with others and push their changes for deployment seamlessly?
I believe the first one would be a better choice for this. But you have to make sure that since there are multiple data models in the same tenant, which itself is a rare thing, right? But if you have something like that, then you have to make sure that you always create a feature branch before deploying anything into the development branch, right? And you name the feature branch accordingly based on like what domain and what data model changes you're doing, right? But definitely the first branching strategy would be more suitable um, for such kind of use cases because it's complex inherently.
And then there was one more question about the L3. Is there anywhere the edition update for the L3, which is deployed in the tenant through pipeline, will be stored?
Um, Not, I mean, you can choose to store it somewhere if you want to. So it gets stored in two places, right? One is the repository, of course, like wherever your L3 or business configuration is committed to, that repository will contain the copy. But once it is deployed, that gets also deployed to the corresponding tenant, right? So a version of that L3 is stored there too. So I think those are the two places. And you can choose to store it elsewhere if you require it, right? But totally depends on what you want to do.
Okay. I think that last question was in relation to the question before it. So I think we're okay, Snail.
But Utsa, I would like to ask you if that answered your question, if I interpreted it correctly or uh, something else.
I you are asking for that where it will be stored, right? For that question,
Yep,
right?
yep, yep.
So I was asking that, let's say you are doing the comparison, right? So let's say you have
Mhm.
created the source system. So when you
Yeah,
are it is actually checking those steps, right? So
yep.
is it in the snapshot? Like you remember that when we deploy any UI modeler, sorry,
Hmm.
the L3 through data modeler,
Yeah.
right?
Uh-huh.
Then it creates a tab difference, right?
Right. Uh-huh.
And here we only can extract the information that whatever the changes have been done, right? So that is through when
Correct.
we are trying to do from data modeler. So the
Correct.
same, like when we are doing this checking, so at the time, like after post deployment, is there any kind of, let's say, detail would be stored, like any of the repository or any of the folder about whatever the changes that has been pushed?
Yeah. So for that, right, like with every commit that you are pushing to the repository, if you click on that commit, you can see what changes went through that commit, right? So uh, that's one of the place I can think of where you can see what got deployed with each commit, and you can selectively analyze that. So not very similar to what you see in the data modeler, but definitely one of the way to do that, visualize it.
Sure, thank you.
And I think that's all the questions.
All right.
And we're right on time. So thank you everybody so much for joining today. As always, the link to this recording will be available on community by tomorrow. And I hope you all enjoyed the show, and I hope you'll join us in our next show coming up in 2 weeks. Thank you.
Thanks, everyone. Bye.
Bye.